What is the best thing to put into a pumpkin pie? Your teeth. Today's lesson is on rational numbers. We're going to identify and graph rational numbers, and we're going to evaluate fractions containing variables. The Indiana Academic Standard is 8.1.2. A rational number is any number you can write as a quotient, a over b, of two integers where b is not 0. In other words, if it can be written as a fraction, it is a rational number. Pause the video if you need more time to copy down the notes. Don't forget, you need to record a question that we can discuss in class tomorrow. Taking a look at this graphic organizer, we're going to use it to help us understand how all these different numbers are tied together. First off, we're going to look at what are whole numbers. Whole numbers are exactly that. They're whole. There's no fraction, there's no decimal, there's no negative. It's just whole numbers. Some examples are 75, 0, and 3 over 3 is considered a whole number because it simplifies to 1. The next category includes integers. Integers are going to include all your whole numbers, but then they're also going to include anything negative. So negative 1, negative 7 over 1, because that simplifies to negative 7, negative 103, and negative 12 over 6. Not only does it include the negatives, it includes all the whole numbers. So all whole numbers are integers also. The last group we're going to look at is rational numbers. Rational numbers include anything that can be written as a fraction. So 6 over 7, negative 3 over 4, 21.84 with a bar notation over the 4 is a fraction, can be written as a mixed number. Negative 7 over 2, 0.25, and negative 4 and 7/8. If you can write a number as a fraction, it is a rational number. Now, probably the most famous irrational number is pi, because an irrational number is a number that's a decimal that goes on forever but never repeats. So a non-terminating, non-repeating decimal are irrational. Pause the video if you need more time to copy down the notes. For example 1, we're writing equivalent fractions. We're going to write two lists of fractions equivalent to 2/3. To begin with, we have our 2/3. Then we're going to write an equivalent fraction that's over 6. Well, 3 times 2 is 6, so 2 times 2 is 4. Then we're going to write an equivalent fraction of something over 9. 3 times 3 is 9, so 2 times 3 is 6. Now let's take a look at the examples on the bottom. Now our numerators and denominators are both going to be negative, because to change 3 into negative 3, you're going to multiply by negative 1. So 2 times negative 1 is negative 2. So we end up with the ratio negative 2 over negative 3, or the fraction, negative 2 over negative 3. For the other example, we have 3 turning into negative 6. That would be multiplied by negative 2. 2 times negative 2 is negative 4. Pause the video if you need more time to copy down the notes. Don't forget, you need to record a question that we can discuss in class tomorrow. Try the quick check problems on your own. Write 3 fractions equivalent to each fraction. Try the problems. Actually, pause the video, try the problems, then turn the video back on to check your work. Remember, if your answer doesn't appear here, that doesn't necessarily mean that it's incorrect. If you're not sure, please check with me in class. Check your work. See if you came up with the same answers. Remember, if you didn't have the exact same answer, check with me on Monday or when we have class next to make sure that you've done them right. Pause the video if you need more time to copy down the notes. Don't forget, you need to record a question that we can discuss in class tomorrow. Use the number line to order the numbers -3/4, 0.5, 0, and 1/3 from least to greatest. Well, you can take a look at this number line and know that -3/4 is going to be the smallest number out of all of these because it's a negative number. So we start with -3/4. Next on the number line would come 0. Next on the number line would be 1/3 because 1/3 is less than half and 0.5 is half. And finally, it would be 0.5 for the last number. Pause the video if you need more time to copy down the notes. Don't forget, you need to record a question that we can discuss in class tomorrow. Now we're going to be evaluating fractions with variables. A fast sports car can accelerate from a stop at 90 feet per second in 5 seconds. What is the acceleration in feet per second Use the formula A equals F minus I, where A is the acceleration, F is the final speed, and I is the initial speed, and T is time. So A equals F minus I over T. We know that the final speed is 90. We know that the initial speed was 0 because we were stopped. And we divide it by the time, which is 5 seconds. So we have 90 divided by 5. 90 divided by 5 is 18. So the car's acceleration is 18 feet per second. Pause the video if you need more time to copy down the notes. Don't forget, you need to record a question that we can discuss in class tomorrow. Try the quick check problem number 2 on your own. You're going to use a number line to order the numbers -1/2, -4/10, -2, and 0.9. Remember, if you're not sure about what order to put them in, you can always change all the fractions into decimals. That sometimes makes it a lot easier for people to understand. Go ahead and try number 2. Pause the video, try it. When you think you know the answer, turn the video back on and check it. Go ahead and check and see if you have this order: -2, -1/2, -4/10, and 0.9. Try these 3 quick check problems. Pause the video, work them out. When you found your answers, start the video again and check your work. Check your work and see if you came up with the same answers. If you didn't, be sure to change them. Pause the video if you need more time to copy down the notes. Don't forget, you need to record a question that we can discuss in class tomorrow.